Well, hello, Algebra. Hope everybody's doing okay. I'll be honest, I'm a bit tired. It's been a long day for me. And so I know I think this is happy Friday for you. Been a long week for you. So let's get through um, example 3B through 7. Get your work and get this done so you can get to work, get home, and take the weekend off. And we'll talk about your test on Monday. I trust you have already checked your homework. So let's just dive right in and start working through these examples. We left off on 3B. So that's we're going to pick up here again, example 3B. So let's make sure your book is open to page. Let's see, what page is this supposed to be? It's supposed to be page 500, it looks like. Page 500. So 3B, we're still just doing pretty straightforward what's one for pretty straightforward reduction, writing in simple terms, simple reducing. So 14k squared over 2k cubed. I should have wrote that on separate lines. That'd have been easier. All right, so here again, you can just do a shortcut and do 14 divided by 2 is 7, and then k squared divided by k cubed. It leaves you a k in the denominator, and it's 7 over k. That's easy enough. We want to do it the longer way, just so that when we do it using the longer way for more complicated things, it'll make more sense. So let's write all the factors of the prime factors of 14 out. So we know that's 2 times 7, and the factors of k squared are times k over, and the factors of 2, of course, are just 2, and the factors of k cubed are times k times k times k. Now, I can ask what I can group together that's in common. I notice 2kk, 2kk, those are together. So I can write 2 times k, put those in a group. That's your 2, your k, and your k, right? And 2 times k, again, your 2, your k. Put those in a group. Times, I'm left over with a 7, so times 7, and I'm left over with a k. So now I've used everything. And so I'm just left with here a very straightforward 7 over k is my answer. So 14k squared divided by 2k cubed reduces to, as you can see in your book, 7k. Straightforward, pretty easy. I don't think that's too difficult. Now let's go a little more complicated, not a lot more complicated, but just a little bit. Let's look at example 4, 4a. And this is going to be 3x minus 12 divided by 5x minus 20. Now I could do a long polynomial division here and write it in long form, or I can just start factoring these. What can I factor out of 3x minus 12? Well, you can see both of the terms are divisible by 3. You should be able to just see that. We've done this before. So 3x divided by, let's factor out the 3. 3x divided by 3 is just x. Negative 12 divided by 3 is negative 4. All right. And then 5x minus 20. I can factor out the 5 because 5 goes into both. So factor out the 5. 5x divided by 5 is just x. Negative 20 divided by 5 is negative 4. And sure enough, x minus 4 over x minus 4 are going to cancel out so that the answer is 3/5, which is to say that 3x minus 12 divided by 5x minus 20 just reduces to, or can be written more simply as 3/5. Those are equivalent expressions. So again, we just factored out, crossed out what's in common, as we've always done, crossing out, and then you write your answer. Let's do example B, 2y squared minus 8. Please make sure you get your signs right. You're going to see they're important in just a moment. Over 2y plus 4. First thing I can do is factor out the 2 from both of them, actually. So because 2y squared and 8 can factor the 2 out. So 2, divide 2y squared by 2, I get y squared. Divide negative 2 by 2, I get, I'm sorry, negative 8 by 2, I get negative 4 over, again, 2y plus 4, factor out the 2. 2y divided by 2 is just going to be 2. Positive 4 divided by 2 is going to be positive, let's say 2. That should be y. That's y with a positive 4. positive 2. Yep, that's what it should get. And so now I can certainly cancel out these 2's, but before I do, I can also notice that y squared minus 4 is perfect squares and its differences, right? Y squared is a perfect square, 4 is a perfect square, and they're separated by a subtraction. So if you don't remember that, check your last chapter. Here, we can just very quickly apply the rule and say, let's keep our 2. I can take the square root y and make one positive and one negative. 2y minus 2. And here we can just keep that 2 times y plus 2. And now the 2's cancel out. The y's plus 2 cancel out. And this y plus 2 is all that's left. And that's my answer. So 2y squared minus 8 divided by 2y plus 4 is just going to reduce to y minus 2. That's going to be our answer. Again, what am I doing? I'm just factoring out, writing these as simple as I can, crossing out what's in common. Let's go on to example C in your book. M squared plus 2m minus 8 divided by 2m squared minus m minus 6. So again, I'm just going to simplify these. So this should be pretty straightforward. These are both trinomials. They're just quadratic equations, so I can factor them to binomials. What are the factors of negative 8 that give me positive 2? Well, I can take positive 4 times negative 2 to get, and then I add those to get positive 2. So m plus 4 times m minus 2. Divide that. 2m squared minus m minus 6. I can just put the 2m on the one side and put the m on the other. All right. And I've got negative, negative. And so one's got to be negative and one's got to be positive. When you play with it, what you're just going to see is going to be positive 3 and negative 2. Factor that out. You're going to see that's going to work. Simple guess to check foiling will work. Now, I notice my m's minus 2's are going to cancel out. So the answer is it reduces to m plus 4 over 2m plus 3. And that's as simple as it gets. Again, don't let this freak you out or frustrate you. All you're doing is what we've been doing now for a month. All you're doing is just factoring these guys out into binomials, crossing out what's in common. And let's finally do example D. Well, not finally, but for example 4. And here we're going to do some grouping. 4m plus 12 minus mp minus 3p divided by 5m plus mp. I'm trying to be very careful and get my signs just right. Plus 15 plus 3p. Now we have all these terms. We just want to go ahead and group these guys up. And of course, very often if you were doing more complicated math, you have to kind of play with it and figure out what groups work. But they're giving you the groupings. You're just going to try this first, and it's just going to work. You're going to group that. You're going to group that and make sure that you keep that negative inside. So I made that negative a positive because we're adding the two negatives. That. And now I have 4 groups. And once I have the 4 groups, I can factor each group and pull the greatest common factor. I mean, not greatest, pull the factoring out of each group. And if you don't remember this procedure, watch me do it and I think you'll remember, oh yeah, we did that with a couple weeks ago. So 4m minus 12, obviously I can factor out the 4. So that becomes 4 times, well, 4m just becomes m, divide 12 and 4, and I'm going to get 3 plus 3. And then negative mp minus 3p, I can factor out the negative p, so minus p, negative mp divided by negative p is just going to be m. Negative 3p divided by negative p is going to be positive 3 because the negatives get factored out. 5m plus mp, I can factor out that m, gives me m plus, I'm going to go with the 5 plus p, right? And then I have 15 plus 3p. I can factor out a 3, positive 3. And 15 divided by 3 is 5, and 3p. This leaves me with a p again. Now, notice these guys match and these guys match. So what do I do when I have that? I can just leave my m plus 3 on the top as a group, and then take these guys and treat them as a group. So that's 4 minus p over, I can keep my 5 plus p, and I have m plus 3. And notice what I have. These two match, so I can cross them out, and I'm left with my final answer, 4 minus p over 5 plus p. And that's my answer. Okay. Lots of steps, but I don't think any of it is something that you can't do. It's just a matter of grouping them, factoring it out. Once you've factored out, you've got to remember this little step right here. Combine your groups and then cancel out what you have in common. Let's move on now to example 5. On the next page. All right. And by the way, I think that was actually the hardest one. I personally don't think they're a lot harder from here. X minus y over y minus x. Now, what I want you to notice with these is that these are backwards. X minus y, y minus x. If I were to rewrite x minus, if I were to rewrite this bottom one, it would be negative x plus y. So you can see the two are they're just opposite of each other. So when you do that, they're just going to equal -1, but let me prove to you it's going to be -1. So I'm just going to factor out the -1 out of the bottom. I could factor out the -1 out of the top if I wanted, but the reason I wanted to do it off the bottom, it doesn't matter which one. Let's just write negative x minus y. Let's rewrite this, put the x in my order, negative x plus y. You see, I just rewrote the order, right? If I were to do this, I want to factor out that negative in the front. So then if I were to factor out the, sorry, put that in the wrong place, -1, well then -1 taken out of that negative x becomes positive x minus y over x minus y. Well, then I can quote unquote factor out a 1 because it's not going to change anything. And now these just cancel out. That's cool. Look at that until it makes sense. And now I have 1 over -1, which just reduces to -1. That always works. We're going to see in other minutes, it's just always going to work. So anytime you have them that are opposites like that, that's just going to turn into -1. All right, that's all that is. So you can play with that more. I could have done the same process and done the top rather than the bottom, and it would have worked out exactly the same way. You can see that done for you here. I'm not going to do that. I encourage you to play with it. If that doesn't immediately make sense, I want you to go ahead and work that out, and you can see that. I'm also not reading these cautions. You can read those. They are worth your knowing. But again, when you play with all these, in fact, example 6, let's go ahead and do example 6a. We're going to see example 6a is just another one of the we just did. Example 6a is 2 minus m over m minus 2. Now, again, I'm going to do more work than the book. The book is just going to point out that they're opposite. So it's a -1. I'm going to show you. So let's rewrite that as -2 plus m over 2 minus m, because I just want you to see, it's easier to see this way that they're opposites. Factor out the -1 from the bottom, as leaves me with positive 2 minus m. And then that gives me 2 minus n up top. Let's factor out a positive 1, so those can be crossed out. 1 divided by -1 is -1. Again, anytime you have opposites, that's the way that's always going to work out. Getting near the end of our time here. Example 6b. 6b is 4x squared minus 9 divided by 6 minus 4x. Now, the first thing that we want to do here is recognize that I have perfect squares, don't I? 4x minus 4x squared. Is that a perfect x? Yes, it is. Is 9 a perfect square? Yes, it is. Is that a subtraction? Yes, it is. So it's a difference of perfect square. So let's just do our little rule. What's the square root of 4x squared is 2x. And square root of 9 is going to be 3. So make one a positive, one a negative, plus 3. And then rewrite it. 2x minus 3 over, and 6 minus 4x. Well, these aren't perfect squares, but I can factor something out. What can I factor out here? What can go into 6 and 4? Well, clearly 2 can, right? So 2, well, 6 divided by 2 is going to be 3, right? And that's going to be negative 2x. And now you ought to notice something. 2x minus 3, 2x, 3 minus 2x. Yeah, 2x minus 3 and 3 minus 2x. What do you notice? These two are, in fact, opposite, right? So if I were to factor out that negative 1, we can rewrite that as, let's go ahead and rewrite 2x plus 3 times 2x minus 3. And then 2 times, we're going to factor out the negative 1 out of 3 minus 2x. That's going to be 2x minus 3. All right. And now I can just cross these out. 2 times negative 1, it's going to be 2x plus 3 over negative 2, which is just the same as negative 2x plus 3 over 2. And that becomes my answer. So again, I look at these, and again, I'm just telling you as a teacher, I look at this and I feel like all the steps sometimes, even when I'm walking through it, it feels kind of complicated, but I do these without looking at my book. I'm solving these right here to show you it can be done. You just walk through the steps. You just got to remember what you're doing. In this case, remember, I just took my perfect squares, fracted them out. Notice my 2's, fracted them out. You're just doing the next thing that makes sense. You don't memorize this stuff. I didn't memorize this stuff. You just do the next thing that makes sense. Factor it out. Oh, I see that these are opposites. Factor out the negative 1, and then I can you're just going step by step. You do what you can with what's in front of you. That's how you solve these, okay? And then C, I'm not going to write it out. I do want to notice that 3 plus R and 3 minus R, these are not opposites in the same way. And if it's not just obvious to you that that's not obvious, I want you to literally write down 3 plus R and 3 minus R, and then write down 2 minus M and M minus 2. Write these side by side till you can see why this is the opposite of this. It'll click with you. You can probably already see it. Let's finish right here. I'm not going to read all this. You can read all this with the example in 7. I'll get right to the bottom line of example 7, which is our last thing. We have the equation negative, let's put it where it's supposed to go, in the middle. Negative 3x plus 2 divided by x minus 6. All right, so here's our expression. You've probably noticed, or at least I will point out to you now, that having different ways to write things can make it easier to group things. So you may, when you have things in this form, not be able to group anything together. But maybe if you regrouped this same or rewrote this same equation different ways, you'd be able to factor or group. So what we're going to get at here is this one expression has 4 different ways it can be written depending on what you do with this negative. I can apply the negative to the numerator, or I can apply the negative to the denominator. If I apply it to the numerator, here's one way. I can do negative 3x plus 2 over x minus 6. That's one way that I can write these two mean the same thing. Also, I can distribute this negative. So negative times 3x is negative 3x. Negative times positive 2 is negative 2 over x minus 6. That also means the same thing. Alternatively, I can also apply it 3x plus 2 to the denominator, x minus 6. That's another way that I can write this. this in this way, and then I can distribute this negative. So 3x plus 2 over negative times x is negative x. Negative times positive 6 is negative times negative 6 is positive 6. And that would be the fourth way. So that way is number 1, number 2, number 3, number 4. 4 different ways that I can write this one equation, and you write it the way that makes sense to you. The write it the one that, like, if you can't do anything with it, if I write it different ways, then suddenly I can do something that I couldn't do before based on whatever you have in the context of your problem. Again, the big thing I want you to kind of walk away with when you're doing all of these problems is just when you're looking at a problem in front of you, you're just rewriting it in ways that you can take the next step forward. So going back to our other examples, like way back here, I'm just reducing. Right here, what do? I'm just going to factor out the 3. I'm just going to factor out the 4. Here, I'm just going to factor out the 2's, which leaves me a perfect square. I'm going to factor the perfect square. I have two trinomials. I'm just going to factor the trinomials. Oh, now notice I can cross these out. Nothing else I can do. These, I can group it. Oh, now they're grouped. I can pull. You see, I just do what's in front of me. And just, so when you look at any one of these, look at the problem in front of you and say, what can I do to this? And in this book, it's pretty easy because it tells you, look back at this example, just do what's in front of you. I see these are opposites. Okay, well, that means it's going to be -1, right? Here, I have their perfect squares. I can factor out that. Oh, that leaves me with 2 opposites. They become -1. You just do whatever's right in front of you. So that's what you're doing. That's what you're practicing. Your homework for the weekend, unless you finish it in class, is going to be picking up, I believe, on page 506, starting number 34. You're going to do last column. So 34, 38, 42, 45, 48, 51, 54, 58, 62, 64, 68, 66, 68, and 70. I'm not going to ask you to do 71 or 72. So that's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 problems that you got over the weekend. I think you got that. No big deal. So thanks much. God bless y'all, and I'll see you Monday. Bye.